Like in my previous KKSS, what we discussed was what is attribution modeling, and we understood the path and the customer behavior, and went through some methods of attribution modeling. And in that paper, the paper proposed a method of ensemble model of Markov and Shapley value model. So today in this paper also, we will be discussing about attribution modeling, and they have proposed the solution in some other way that I will be discussing. So this paper basically take into account the solution of it is proposing the solution using logistic regression and Markov chain models. And this paper is based on B2C scenario, where not B2, it is business to customer scenario. So starting with the popularity of digital marketing that is rising continuously. So this graph basically show that revenue generated by internet advertising. So we can see that it is increasing year by year, and in 2017 it is around 88 million. And this is the rate of United States. So as the digital marketing is rising, at the same time analyzing the digital marketing process has becoming more difficult and difficult, because if we will not analyze the process, then how can the strategy can be made for next year? Here we can also see that the share of the global advertising by different channels, we can see that it is increasing year by year. Now internet basically make use of the cookie system to track the user activity. Cookie is basically one identifier which assigned to a user when he or she is browsing a web page. So all the advertisers monitor this cookie level ID to observe the behavior of customers. Now they can be two ways, they can be a click or an impression. Basically, click means if the user is clicking in the ad or touching in the mobile device, which send them to another URL, and which indicates an interest or an engagement. So this is a click. And impression is basically the view, if we just view the ad. So there are two type of action can be there for any advertisement. So in digital marketing, the most common problem is that how can we optimize the marketing spend in such a way that the number of conversions get higher. So in this paper, machine learning approach has been proposed, and also machine learning approaches is becoming in use more and more to solve this attribution modeling problem. As we discussed in previous KKSS also, I will just give a quick definition that what is attribution modeling. So basically, attribution modeling is used to determine how the credit for sales or conversion is allocated to every touch points in conversion path. So what the touch points means, the channels that a customer goes through till the conversion, and this process basically help in increasing the ROI. Like if you can see this picture, this C1, C2, C3 are representing different channels. Let me explain taking an example. Like C1 is like customer is seeing an advertisement in an Instagram. Now, by clicking through the Instagram, the customer may, let's take example, goes to YouTube. So he saw the more information about the product, and after that, let's say he don't go to he just stopped after viewing that YouTube video, and after that, sometimes some days after, he saw one more advertisement from same thing in Facebook, and he got interested, and now he searched that in Google, and after that he came to the website and he brought the product. So this is the scenario that that is there in digital marketing. So the main aim of the attribution modeling is to decide and give the credit to each of these channels according to their effectiveness to the getting customer converted. So this is basically attribution modeling. We have discussed the traditional models before also, but just for the what are the limitations of that model? Like in first attribution modeling, it basically doesn't convey anything about the rest of the touch points. All of the credits is given to the first touch point. It is easy to implement, but it is not a good way for the attribution modeling. Same with last touch attribution modeling. It gives no information about previous touch points, and the credits is given to the last channel that a customer has been gone. In linear attribution modeling, it is divided equally, taking into account the first two attribution modeling, it is considering all the channels, and giving some information about all the channels. But in the same case, it cannot be true that all the touch points contribute equally to the conversion. Then there comes the time decay attribution modeling, in which the credits is given according to the closeness to the conversion. So it also considers all the paths, but there can be some cases in which initial touch points might have greater impact. That's why there comes positional based attribution modeling, in which the first and last touch points are given more credits, and middle touch points are given less credit than and equally distributed. So the problem comes with here is that it is not necessary that the touch points that are in middle part contributes less to the conversion and contributes evenly also. So these were the traditional models and their limitations. That's why here comes the algorithmic attributions, in which we can use machine learning to credit the different touch points using the historical customer data and giving weights to the different touch points, learning from the data. So the paper suggested it has used the logistic regression and Markov model. So I will just give a brief introduction about them. So logistic regression basically gives the probability of something happening based on the independent variables. So here the probability will be if the customer is getting converted or not. And for the Markov chain, it is basically a Markov chain, like it is sequence of possible event in which the probability of each event depends only on the previous state. Like here you can see this vertex is basically stages, and the paths are basically probability of going into stage C from stage A. Markov chain, like other than attribution modeling, it has been previously used in different purpose, like weather forecasting and like Google PageRank algorithm, etc. Now here comes the data. So there are three. The first data is ad form, which is from advertiser side. It contains 3 files: clicks, impressions, and campaigns. So basically each file contains information about the specific transactions, and clicks contain information about the click of that user, and impressions contain the information about view of that particular campaign, and basically campaign is the channels, a list of all the channels, and clicks and impression are collectively called the events. And then there is second data, which is Google Analytics on website side. So it basically shows the conversion, like a user is going to the website and buying a product. So it contains the information about like the user ID and if it is converted or not. So the 2 data has been made. First is user level and second is sequence level. The user level data looks like this. Basically, 1 and 2. 1 is the click event, and 2 is the view event, impression event, and A and B are the different channels. So like this, for every user the data is made, and the last dependent column is it is converted or not. So there are some data pre-processing steps that has been followed. Like there can be sometimes that user have disabled the cookie, so cookie ID will be missing for that, so they are removed. Also there can be some duplicate cookie ID, so in that case also like second duplicated row is removed. One drawback of like this data preparation is that there can be multiple conversion of a user, but after one conversion the data has not been used here. Just till the first conversion the data is made. Now there comes the sequence level data, in which the pathways are constructed for each user. I will just go to the data. So it will look like this. The order of the path channels, the path is created and if it is converted or not. Here also A and B represent the different channels, and 1 represent the click campaign and 2 represent the impression. So in these 2 data, the models were used. So firstly, they have done some exploratory data analysis. Just a second. Like this is basically conversion density. It is of the weekdays, and the deeper the purple color represent that more users have converted at that day and that time. This is hours of the day and this is a day. Similarly, there is event density, like click event and impression event. The density of that events, the higher the deeper the purple color represents that more user activity has been observed in that time of that particular day. And here the for every channels the time to conversion data has been recorded. Like this is starting from this channel, what is the time taken till the conversion. Now there is one descriptive data analysis. Basically, click-through rate is calculated. Click-through rate is like how many times a user has clicked on the advertisement when it is shown to the user. So there is funnel analysis also. It basically shows that for every channels, in which state it was in the particular user path. First event being the first stage, last event being the last stage, and mid pathway is basically any stage between the last stage and first stage. So from this like graph or chart visual, we can say that this indicates basically that for the display one, we can see that we did not find any last event. So the insights can be drawn that this display one is not effective enough so that they can go to the user can go to the website. So they are not effective enough. Now comes the proposed method. So the independent as we see, the independent variables are basically the marketing channels and dependent variables conversion. A model is trained on this data, and after the training, the coefficients are extracted for each channel. As we know, this is the mathematical expression for logistic regression. There will be all the independent variables and a coefficient associated with that particular independent variable. So all the coefficients are extracted for each channels, and then the coefficient will be used in the attribution modeling. So some calculations have been done to the coefficient to take out the credits for each channels, and using those coefficients only, the weights has been given to all the channels. So this was for the logistic. This was the approach for logistic regression, and but since the data set can be highly imbalanced, so various methods have been used for solving this imbalance problem, like random sampling, just taking out 50 equal amount of data for the non-convergent data will be more. So just equal to the convergent data is taken out randomly from that non-converted sample.
So just to give you an example of Rupali, I hope it's okay to add something.
Yeah, sure.
Yeah. So some time ago, we were actually looking at, I think, the churn modeling that we did, and also the lookalike modeling that we did. We had a big sort of imbalance problem. The imbalance problem here means that, let us say you have 10,000 entries in total, right? But you have, let us say, 100 conversions. Right? So how much is 100 on 10,000? What percentage is it?
Just 1%.
1%, right? So what we are trying to do is to predict the 1%. But the algorithms, the way they work is they're trying to learn not just from the conversions, but they're also trying to learn from the non-conversions as well. So the signal that it gets is actually the 99%, not the 1%. Okay, because of which some of the algorithms will be not be able to find the conversions appropriately. So for this, what we try doing is we increase the signal, which is we try to increase the conversions, okay, so that the system the algorithm gets the point, so to say. Oh, Jagdish is here. Jagdish, you want to add anything?
Pretty much you've covered it, Chaitanya. But yeah, class imbalance. It's called the problem. It's a typical a situation that happens in many of the classification problems. One of the good examples can also be the fraud cases, right? So typically we use credit card, and very rarely we do get transactions which are flagged as fraud or fraudulent. So similar there, the class imbalance will be even higher, no, way less than 1%. But the idea is you can, though it is less than 1%, but those are very crucial to identify. So we cannot just miss out on those things, and that is where there are a whole bunch of techniques that come like SMART, and there is few other called Edison, etc., that try to amplify the signal that is coming from this weaker class, smaller class, and that will help the models learn better. So there are several other applications where this is very predominant. One other use case will be on the medical image classification or medical data classification for any disease, rare diseases, etc. So there also data will typically be imbalanced.
Okay, excellent. All right, Rupali, back to you.
And there can be one more problem generally seen in various regression models, the overfitting problem. So there are some regularization method for solving the overfitting problem, like L1 and L2 regularization. Now coming to Markov chain, the sequence level data is used here, and the pathways has been constructed, and different probabilities are calculated using Markov chain. Let me see, this is an example. Start and conversion or not conversion, and these are the paths involved. So for it, I will explain how the approach is for attribution modeling. So these are the arrow shows basically it has gone to C2, and the value is showing that is probability. So how it is done is, first calculation is done for a particular path of conversion, the probability of conversion using that path. Like here it is calculated, and the removal effect has been used here. Basically the particular channel will be removed, and now we will see what will be the conversion probability. So it is calculated, it is 0.30. Now the removal effect of C1 will be basically the probability without C1 and probability with C1 of conversion, probability of conversion. So here we see that it means that the channel C1 contributes 67% of conversion in consumer journey. So like this, it is repeated for every channel, and the credits is calculated. So this was the approach proposed by this paper. The first was logistic regression, and second was using Markov chain. That's it from my side today.